All right, so yesterday, right, we started talking about circles. Today we're going to finish our talk about circles and examine one more thing there with circles. Okay, so we'll just call this, like, circles part 2, I guess, something like that. Not very exciting. Okay, there we go. All right, so much like one of the questions we had in the homework, our directions, I just want to start out with a question or a problem, so to speak. So let's find the center and radius. Okay. Of the circle below. Okay. And so let's see. I'll start out here with x squared plus y squared plus 6x minus 10y plus 18 equals 0. Zoom in on that some too for us. Okay. So this is a circle equation, right? This is a circle equation. Okay, you may not believe me because it doesn't look like standard form that we're used to. Remember, standard form is that x minus h squared plus y minus k squared equals the radius squared, right? That would be the standard form that we're used to seeing. But looking at this, that does not, our problem here, right? Our circle does not look like this at all. In fact, it looks like, if we're trying to pull information out here, it's like, well, we have an x squared, we have a y squared, we have like an x and y, we have a number here, and then we have equals 0, so it looks like maybe the radius is 0, which wouldn't really make a circle, right, because radius of 0 is not a circle, it's a point. Any ideas here about what to do? So, we could, for example, like try and get a number over here. Like we could, this is an equation, right? So we could do the same thing to both sides. So, that equation rule. So we could, like, for example, I don't know, subtract 18 from both sides. But then, this makes things even more confusing now, because now we're saying our radius squared is a negative number, which, but maybe that's not still the radius. Maybe there's, something else there. We're going to stop there. We're going to pause and kind of scratch our heads a little bit with that. But let's jump into a little tangent here of completing the square. Okay? Because this is what's going to help us in our quest to figure out what the center and radius of that circle equation is going to be. Okay? But we'll hold off on doing it right in here, because this is going to be a lot. Well, not a lot, but it's just a little more complicated than I want to start out with. So completing the square, okay, is a term, right, is a strategy used to take a kind of a quadratic relationship there, or a quadratic expression, or an equation, I guess, like that, and change it into a perfect square of two binomials. It's like right now, x squared plus 6x minus 7 equals 0. That's not a perfect square. It factors, though, right? What is x squared plus 6x minus 7? What does that factor to be? Can anyone see what it factors to be there? What could you factor that to be? So, x and x here equals 0. What would this thing factor to be? Yep. Yeah, so minus 1 and plus 7, or plus 7 and minus 1, however the order is that you want to put it there. Exactly right. Okay? But then, since it factors that way, that means that it's not a perfect square. Okay? That means it's not a perfect square because these two things are not different. They're different. They're not the same. And there are situations that arise sometimes when we do want to achieve a perfect square. But of course, this thing, is not a perfect square. So what can we do here? How can we fix that, so to speak, right? How do we fix that? Well, if we take our quadratic here and we make some adjustments to it. Okay, and you might, see it in different ways. Sometimes your teacher would have you add 7 over, okay, maybe, and that's, something like that. So you just have the x squared plus 6x, So let's take a look at that maybe and just try it that way. and leave a little bit of space right here. Okay, so we're going to add the 7 to both sides, but leave some space. Okay. All right. And, you know, I guess I can't really come up with a good way for us to, yeah, anyway. The strategy for completing the square is to take half this middle term, okay, right, and then square it. Okay, so we're going to take half this middle term here and then square it. That's going to be the way that we can complete the square here. That kind of like technique or that kind of like strategy here will allow it to happen. Okay. All right, so half of 6 is 3. Squared is 9. So we're going to add 9 here. But of course, we can't just like bring a number in out of nothing, right? We need to like, you know, make this work. Because right now my equation's unbalanced. So if I add 9 to the left-hand side, I also have to add 9 to the right-hand side of the equation to make it stay balanced. Okay. And so now I can factor this again, but x squared plus 6x plus 9, when we factor it, now factors to be what? What will that x squared plus 6x plus 9 factor to be? What would it be? What's that? Yeah, x plus 3, right? X plus 3 and x plus 3. It's a perfect square now, right? It's x plus 3 quantity squared. You're multiplying it by itself, right? And then it's equal to, though, over here we've got, what is that, 16? Yeah. So perfect square. Now, obviously, it's like, well, how is this helpful here, right? That's not very helpful. I mean, we can still solve it, right? So, I mean, just like over here in the earlier one, you know, with the original version, we had the x minus 1 times x plus 7 equals 0. So, you know, we can use the 0 property here. And then say that x is 1 and x equals negative 7. Okay. So we have the solutions for it here. This, again, it's supposed to be equivalent, right? I mean, I started out with the same thing. I added 9 to both sides after moving the 7 over. So this thing, this relationship, this equation, is the same as this equation right here. It's just, you know, altered a little bit. And so I should be able to solve from here and still get the same solutions as I did here. It should be the same thing. And in fact, it is. If I take the square root here of both sides, okay, I'll be left with x plus 3 over here, and then what will I have over here on the right-hand side? 4 and negative 4. Yeah, we're in an equation setting. There's no context here other than we're just solving. So it's plus or minus 4. And so that means x plus 3 equals positive 4, x plus 3 equals negative 4, right? And we can subtract 3 from either one of these. We get, well, what do you know? 1 and negative 7. Okay, so we do get the same solutions. It is the same, you know, it is, we're talking about the same thing. Okay, it's just written in a different way. Okay, so there it is. Okay, and so this process right here, this process, you know, I would say right there is completing the square. Okay, we started with something that was not. We started with something that was not a square, right? Not a perfect square. All right, but it did factors. That's fine. Okay, whatever, we go from there. Here we take that incomplete square, we add a value to it to then complete the square, to then make it become a perfect square, so that then we, you know, can solve it or use it in however we want, use it in whatever way we need to. Okay. So actually, I'm going to have you guys try that here. So let's try another one. Okay. So let's complete the square again. That's going to be our example. We'll get back to our circle problem here in just a moment. Alright, so our directions here are just complete the square, and then we'll have you go ahead and solve too. Okay, just why not get that solving in there too. Okay. So let's see here. Let's say we've got m squared plus 10m plus 14, and that's equal to negative 7. Okay. Right now, looking at that left-hand side, it does not factor, right? The left-hand side doesn't factor. In fact, we really wouldn't want to factor. We would want to add the 7 over. Okay. So, I mean, you know, we could again here kind of try and factor this. We could add that 7 over, and then the m squared plus 10m plus 21 at that point. That would factor, I think. Yeah. But again, we want to complete the square. So what we got to do here? Well, I'm going to again subtract the 14 over, and then leave some space there where the 14 was. Now we have negative 21 over there. Okay. And so again, the question is, what are we going to add in here? Right? What do we have to put in to then complete the square? So yeah.
25.
What's that?
25.
25, exactly right. We're going to add 25. And of course, if we add it to one side of the equation, we got to add it to the other side to keep it balanced there. Okay. Right. And so then, Anna, what will this thing factor to be then? Yep. Quantity m plus 5 squared. And we can add those two things together and we get 4. Yep. Okay. And again, square root both sides, right? And we get m plus 5 equals, and then plus or minus 2. And so then we get, you know, m plus 5 equals the positive 2. M plus 5 also could equal the negative 2. And so we get m equals negative 3, or m equals negative 7. Those are two solutions. Okay. Questions on any of that? All right. If not, I'm going to have you guys try one then here. So try same directions. Okay, same directions here. Just make sure we're all okay with completing the square, and then we'll jump back to that circle problem. Let's do x squared plus 12x plus 20 equals 0. Okay. Now, yes, this one factors. Okay. So yes, you can solve it without, you know, completing the square. But I just want you to try it with completing the square to make sure you're okay. All good. Thank you. Okay. Okay, so let's go to Sarah. So, what did you do here, Sarah? How did you go about, were you able to get it done?
Yeah.
Okay, so what do we do here?
I started with subtracting twice.
Okay, very good. So we're left with x squared plus 12x equals negative 20 over there. Okay.
And then I took half the middle term and squared it.
Okay.
So add 36 to both sides.
Okay, plus 36 here, plus 36 here. Cool, cool, cool. And then what does this thing factor to be now?
Factored is x plus 6 squared.
Okay, very good. Yeah, it's a perfect square of x plus 6 now, and that's going to be, what, 16 there, okay? And then?
And then I
Square root both sides. You get...
x plus 6 equals positive or negative 4.
Yep, plus or minus, positive or negative 4. Very good. And so then what do we get for our solutions? Then we get x equals...
Negative 2.
Uh-huh.
And negative 10.
And negative 10. Okay. So there you go. Very good. Okay. Questions on any of that? Alright, I said we were going to go to the circle next, but I lied. I want to look at one more thing. Because there's one other little twist that these completing the square problems can result, or can kind of, you know, have, and we want to make sure that we're prepared for that too. So, so we'll do one more here, and it's the situations where you have a coefficient. So, something like that. And again, our goal here, we want to be able to complete the square here. But now we have an extra challenge because we have a 2p squared. Okay? And if we follow, and again, you don't have to write this part down if you don't want to, because this is like, you know, well, it's leading towards something that's not going to be helpful, so I don't know if you want to write it down or not, but I'm going to go ahead and do it. If we followed our normal kind of standard operating procedure that I was just showing you there, right, if we do the 2p squared minus the 8p, we subtract 15 from both sides, so I get a negative 15 here. If I do that whole, like, you know, 1/2 the middle term and square it at this point, we can do that, right? I mean, we can do half of 8, no problem. That's going to be negative 4 squared will be 16, so we can add 16 to both sides here. And then if I try and factor that left-hand side, though, I'm going to have some problems because that technique, right, if I factor this, well, we're tempted to make this p minus 4 quantity squared, right, equals 1. But the problem is if I were to square back out that p minus 4, okay, I would get a minus 8p, I would get a plus 16, but I would not get 2p squared, I would only have p squared. And so the method kind of falls apart a little bit here when we have this coefficient. Okay. So, what can we do? Well, we can still do that same first step that we did before. Okay. Moving that 15 over. Except now what I'm going to do is I'm going to factor that 2 out. Okay? In this case, you know, factoring a 2 out from both of these terms, it's a nice factor, right? Because the 2 and the 8 are both divisible by 2, and so factoring a 2 out is no big deal. But if this were like 2 and this were just minus 1p, you'd still want to factor the 2 out and you just leave behind a minus 1/2. Okay? So I mean, whatever the coefficient is of that p squared term, you really want to factor that out. So we're going to leave then. We're going to factor out the 2 from the p squared minus 8p, and so we're left with p squared minus 4p. And from inside the parentheses, we are now going to complete the square. Okay, we're going to complete the square for this, because now we're just at that p squared, and so we want to complete the square. So we'll follow the normal kind of standard procedure from here, right? So we're going to do half this middle term here and square it. So half of negative 4 is negative 2, squared would be 4. So we're going to add 4 inside the parentheses there. And if you factor this thing now, we still have the 2 out front, and then p squared minus 4p plus 4, that factors to p minus 2 quantity squared, right? That's what that would be. You have a minus 4p for the middle term, and then plus 4 at the end. But then the question is, I got to still balance out over here. Should I put a plus 4 on this side? Because I added 4 in here. And if not, what should I put over here on this right-hand side? Yes. Plus 8. Yeah, why plus 8? Yes, okay, so when I put a plus 4 here in the parentheses, the value, the amount, the quantity that I added to that left-hand side is not 4. Okay, I actually added 8 because it's 2 times 4, 8. So I really added an 8 to this left-hand side, so now I need to balance that out by adding an 8 to the right-hand side over here. Okay, and so then that results in negative 7 there. Okay. Okay, and I made this problem up, so at this point we're kind of stuck because we're going to have imaginary answers as we try and continue to solve this. Okay, so, but that shouldn't happen in your circle stuff. So let's take a look now. Back to our circle question that we had. Okay, but that's how you can complete the square when you have a coefficient of your squared term that's not 1. So let's go back to that question. Find the center and radius of x squared plus y squared plus 6x minus 10y plus 18 equals 0. Okay. So first thing we want to do, move that 18 over, and then also rearrange our terms. Okay, so we're going to rearrange our terms so that our x squareds and x's are together, and then that's going to be 1 completing the square. One square we'll have to complete, but then we'll also rearrange the y squared, and the y terms. Okay, and that's going to be another square we're going to complete, and then that'll equal negative 18 because we subtracted the 18 over. Okay, so again, we rearrange the terms, put together like terms, x squared and x's. Well, not really like, but same variable terms, x squared and x, y squared and y. And now we're just going to complete the square for both of these situations. Okay, so for the 6x, half that is 3, squared is 9, so plus 9. And we'll make sure we add the 9 over to that side too. And then for the y squared minus 10y, half of negative 10 is negative 5, squared is 25, so we add 25. Alright. And from that completing the square, we can take this quantity right here, right, and that becomes x plus 3 quantity squared, and then considering that quantity with the y squared and the y and the plus 25, that factors to be y minus 5 quantity squared, and then we can combine all of our like terms there, and so it's going to be, let's see here, be negative 9, so 16. And lo and behold, now we have our circle in standard form, right? The x minus h quantity squared plus y minus k quantity squared equals 16. Okay, and there it is. All right. So let's see here. Oh my goodness. So Devin, what's our center? What's our radius?
Our radius is 4.
Okay.
And our center is
Negative 3, positive 5. There it is. Very good, very good. All right, well, let's continue here. I think I've got another one for us. Yes. Okay. Let's look at one now. So again, that one was with those single coefficients. Let's do one with like 3 and stuff like that. So that was one example here. We'll do another example. Let's do one with some coefficients. So let's we got 3x squared plus 3y squared minus 6y plus 15x plus 9 equals 0. So this will be our last example, and I'll have you guys try one after that. Then we've pretty much done. I have one more over there I want to show you guys. All right, so here, what would be a good first step here to do? What would be a good first step here? Very first step. To help us out, maybe make things a little bit easier. Yeah, Deb?
Rewrite the equation.
Okay, so how would you want to rewrite it?
I want to make your x terms and your x terms and your y terms plus 4.
Okay, yep, we can do that. So we write it 3x squared plus 15x. I'm going to leave the space there, plus 3y squared minus 6y. And then, do you want to move the 9 over too?
Yeah.
Okay, so equals negative 9. One other thing I want to point out here that we didn't talk about, but something we can do. If you look here, all of the numbers, all of them are divisible by 3. And so let's go ahead and just divide through by 3, because right now we might be tempted to we can factor 3 out here, but actually if the whole thing divides by 3, let's just do that. So we can just divide each thing here by 3. And so that leaves us with just x squared plus 5x plus y squared minus 2y equals negative 3. And this is a perfectly legitimate thing to do, right? You can divide both sides by 3. And now, thank goodness, we've eliminated that coefficient, so we don't have to worry about the extra complicated part of the completing the square. We can just do the normal completing the square here. Okay. Sadly, though, that middle term, the 5x, right, that 5, dividing that by 2 is going to give us 2.5 or 5 halves, right? So the half the middle term there is 5 halves, and then squaring that is going to be 25 fourths. So we're going to add 25 fourths here to complete that square, which we're going to do then to the other side here. Okay, 25 fourths. And then the minus 2y, half that's going to be negative 1, and so squared is going to be plus 1. So then we'll also add a 1 here as well. Okay, so yes, some fractions are going to show up here. My recommendation, okay, my recommendation, keep them as fractions, right? I mean, if unless you're really afraid of fractions or whatever, and you prefer decimals, I'm not going to take points off if you choose to use decimals and stuff like that. But fractions, I think it's so much easier to do the squaring with, and then the arithmetic and stuff. Much easier than with the decimals, I think. But it's my opinion. Anyway, that's going to factor, and that's going to factor to a perfect square, right? So this will be x plus 5 halves squared plus, and then this factors to y minus 1 quantity squared. Ooh, and we got to combine these things over here. So let's see. To add fractions, we need to get a common denominator, right? They got to be like terms, right? Right now we have negative 3 ones, right, and 25 fourths, and then 1 1. So we can at least, let's see, it looks like we need fourths to our common denominator here. So negative 3 is negative 12 fourths, 25 fourths, and then 4 fourths. So that means okay, so let's see here. Negative 12 plus 25 is going to be 13. Okay, plus 4 will be 17 fourths. All right, and so then our center is going to be negative 5 halves, comma 1. And our radius will be the square root of 17 over 4, which is, if we simplify it, is root 17 over 2. So there it is. So yes, there will be some fractions and stuff in there that we want to be comfortable with. There will be some fractions. Any questions on any of that? What do you guys want to try? Otherwise, all right, you're ready. Gotcha. Ready to go. All right, let me give you guys one to try here. So try this one here. X squared plus y squared, so I'm being nice, no coefficients in front of the x squared or y squared terms, plus 4x minus 14y plus 4x minus 19 equals 0. Okay. So again, find the center and radius of the circle. Double check to make sure I wrote that right. Yes, I did. Okay, so yes, that's exactly what I wanted to write. Alright, so I'll kind of come around and help as necessary. Oh, we can get it. There's another plus 4x. So your middle term is going to be 8x there, which is going to affect that and that and then also. And of course your r squared as well. So, look up here. You did it correctly, but just so don't worry about it. Just write that you asked. All right, all right, let's see what we're able to come up with here. Let's go to, is it Raphael? Okay, Raphael. What were you able to, what did you do here? How'd you start? Okay, so what'd you get? So it was x squared, right? And then, very good, plus 8x. Okay, I did throw a little loop at some of you guys there. Okay, there are two 4x in there, so we do want to combine those like terms. I guess that was me being a little bit tricky there. We'll leave some space, right? And then what about the y's? And again, leave some space, and then equals, yeah, 19. We add 19 to both sides there. Good. Okay, so completing the square with the x squared plus 8x, Raphael, what do we need to add there to complete that square? 16, that's right. And we're going to add the 16 over here to keep it balanced. Yep, again, half of negative 14 is negative 7 squared, will be 49. We'll add the 49 over here too. Okay, so when we do that then, these two things are going to factor. What does that x squared plus 8x plus 16 factor to be? Yep. Whoops, not equals, my goodness. Plus, okay, what does this factor to be? Yeah, or y minus 7 squared. And then 19 plus 16 plus 49 is 84. So our center, Raphael, is negative 47. Great. And then what about the radius? Yeah, exactly right. So it'll be the square root of 84, but we can factor a square root of 4 times the square root of 21 there out, and so it is 2 square roots of 21. Very good. Well done. Okay. Questions on any of that? Okay, I have one more thing I want to kind of like just, take a look at, and then we will be done, all right, with this. We'll give you guys your homework, but just one more thing I want to look at here. Let's just say, hypothetically here, that I changed the problem slightly, right? And the only thing I want to change about the original one that we looked at right here is instead of making this a negative 19, let's make it a plus 100. So I'll still have the x squared plus the y squared plus the 4x minus the 14y plus the 4x. But instead of saying minus 19, let's have a plus 100 there equals 0. Okay, y plus 100, well, it doesn't really matter too much what the number is, but I just wanted to kind of change it up a little bit to see what happens, okay? So make that plus 100. So it looks like, the kind of standard thing that we do. So we'll follow the same thing we did before, that Raphael had us do before. So x squared plus the 8x, we'll rearrange the terms there. Y squared minus the 14y, again, rearranging the terms, leaving some space. And we'll move that 100 over to make it negative 100 now. Okay, so again, first step, same thing, right? All I did was just change that negative 19 to a positive 100, and then we move it over, it's now equal to negative 100. Again, the square part is going to be the same too, so it's going to be the same numbers that Raphael had us do, so I'm not going to, spend a lot of time there. We're going to have to add a 16 in here, we're going to have to add a 49 in here, and then to balance it, we'll add a 16 and a 49 as well. There. The square should still be the same, and the y squared should still be the same as well, so it'll be y minus 7 squared equals, and then when we add here, now because again it's now negative 100 instead of the 19, when we add those numbers up, let's see here, so that'll be 55, 65, so that'll be negative 35, I think? Yes. And so now what can we say about this circle? So the center, right, we can say the center is negative 4, 7, and the radius is going to be what? Yeah, it's imaginary, right? The square root of negative 35. Well, again, for right now, we keep it real. So there's no circle, is what we're going to say here. There's no circle. Okay? Because a circle cannot have an imaginary radius. So when you're doing your problems, all right, be on your toes, right? I mean, if you were to run across, a situation like this, you want to first check back and make sure that you didn't make a mistake, right? Because quite possibly, maybe you added something wrong, you just missed something or whatever. That's fine. But if you checked it back again, you're like, wait a minute, I still have my r squared is negative 35, so therefore my radius would be, the square root of a negative number, imaginary, then the answer here is no circle. Okay, the circle does not exist. Okay, and it's not because the radius, is negative or anything like that. It's not because r, it's because the radius is would be imaginary. Okay, and you can't have a circle that would have an imaginary radius, right? It just doesn't make sense. It needs to be a real number there. Okay, so keep that in mind there. Any questions on that? Hopefully that makes sense, right? So keep it real, in other words. Keep it real. For right now. All right. Then, let me give you guys your assignment. So the assignment is not out of the book, okay? It is merely a piece of paper here with 4 problems.